The following is part of a series of occasional videos related to the interdisciplinary and multi-institutional partnerships with the National Science Foundation-funded High Performance Wireless Research and Education Network via the University of California, San Diego. In this video, Scott Cardell of the California Institute of Technology describes cyber infrastructure intensive applications at the Palomar Observatory with a specific focus on a new and exciting Palomar Transient factory. HPWREN is a collaborative cyber infrastructure on research, education, and public safety activities, reaching predominantly remote environments within an about 20,000 square mile area in Southern California.
We're here at the world-famous Palomar Observatory. Behind me is the 200-inch Hale telescope, which for over 60 years has been used to explore the universe. It's one of several telescopes here at Palomar, and in spite of the age of some of the telescopes here, they're kept young and vibrant by new electronic instrumentation, a high-speed network that allows us to get data on and off the mountain, and some very exciting research projects. Over the next couple of minutes, we're going to take a look at some of these telescopes and some of these research projects in more detail. Caltech's Mike Brown and his research partners have made a number of astonishing discoveries with this telescope that have totally revised our knowledge of the outer solar system. The most important of those is perhaps the discovery of a world now known as Eris that's both bigger than Pluto and helped get Pluto kicked out of the planetary roll call. The newest survey here at Palomar Observatory with the 48-inch telescope is something known as the Palomar Transient Factory. The survey was begun early in 2009. We use this telescope and a 100 megapixel camera to look for transient sources in the night sky. These are things that come and go, or objects that vary in brightness. One of the unique things about this is that there's no astronomer here. The telescope operates entirely remotely. We take a picture of the night sky every 90 seconds, analyze that, and then find what's changed in the universe. That's all possible because of this, a high-speed microwave network link that gives Palomar Observatory 155 megabits per second of bandwidth, all provided by the National Science Foundation's High Performance Wireless Research and Education Network, HPWREN. Data from Palomar Observatory is beamed off the mountain, works its way into the internet where it's accessible by researchers at Caltech, Berkeley, and other sites around the world. Data also comes back from the outside world to Palomar via this connection so that astronomers who are using telescopes remotely can seize control of them and have them respond to other events that take place in the sky. An exciting addition is soon expected for the network. A second relay link at 45 megabits per second will give us not only redundant capabilities, but allow us to send data to and from the observatory at an astonishing 200 megabits per second. The data from the Palomar Transient Factory is analyzed remotely, and then coordinates for follow-up observations are beamed back to Palomar and analyzed with the 60-inch telescope. This telescope collects photometry on these objects. Basically, it tells us the brightness, the color, and how those properties are changing. If from those observations, if it's determined that the objects are sufficiently interesting, then other telescopes here at Palomar or around the world are called into action, often during the same night that the first observations were collected at the 48-inch. For any of the transient sources that prove to be sufficiently interesting, astronomers here using the 200-inch Hale telescope at Palomar will get interrupted during the night. They'll be asked to stop their observations and bring a spectrograph into play and get immediate spectrographic observations that should help astronomers learn both the distance and other features about the transient source to help classify it. These observations happen as soon as possible so that other astronomers around the world can be alerted as to what sort of transient this is, and if more observations are needed, they can be called into play as well. The Palomar Transient Factory is a 5-year international collaboration that all begins here at Palomar Observatory, but is really just one example of the many research programs that take place here. Modern astronomers use the Hale telescope and other telescopes here in a way very different from the way astronomers used to when this was new 60 years ago. Back then, they would ride in the telescope, take pictures on glass plates with film, develop them, and analyze them in their lab. Now they're using telescopes here at Palomar, around the globe, and in space. Caltech's partnership with HPWREN allows the Palomar Observatory to have the high-speed bandwidth and connectivity it needs so that it can perform big modern research programs that keep the observatory at the cutting edge of astronomy.